Hello, pre-calculus. Hope you're all having a fantastic day today. It's going to be a good one here. We're talking about long division. And for some reason, there seems to be a very wrong idea about what long division is. For example, a lot of people think that this is short division, right? And that this is long division just because it's a long number or a longer number. I think that's long division. That's not what long division is actually. How long division from your elementary days, like 592 divided by 4. The setup is the exact same way that we've done everything. Now this is all review from Algebra 2. I know you've done long division before, but some of you may have never seen it explained like this. And this is one of the reasons that I love long division. This is actually one of my favorite subjects to teach because it is so simplistic if you can remember your basic elementary division. And I mean elementary division. So if you remember, the first thing you do is look at 4 goes into 5 how many times? Well, it goes in 1 time. And then you do 1 times 4 is 4, and you subtract the difference. Right? 5 minus 4 is 1. You bring down the 9. Now you do 4 into 19. Doesn't go into 1, so 4 into 19 goes in 4 times. 4 times 4 is 16. Gives you a remainder of 3. Bring down your 2. 4 goes into 32. 8 times. 8 times 4 is 32. So if you get a remainder of 0, that means that it divides evenly, right? Well, what if you have a different remainder, like 593? We follow the same process. 4 going to 5 1 time. That's going to give you 4. That's 19. Bring down your 9. 4 goes into 19 4 times. 4 times 4 is 16. 33 goes in 8 times, 32, and you have a remainder of 1. Well, that remainder of 1 comes back up here, and we write it as 1 divided by 4. So it's 148 and 1/4. And the idea of long division is the exact same thing, just with equations instead of numbers. It's the exact same principle, and you'll see what I mean here in just a second. So take a look here. It says use long division to determine that the given polynomial is a factor of f of x. Use the result to write f of x in completely factored form. Factors mean that this times this gives you 592, right? That means that 148 times 4 gives you 592. So 148 and 4 are factors of 592. These are your factors, right? So let's try this here. I'm dividing this, and I'm trying to figure out if this is a factor, so I'm going to divide it by x plus 4. So let's set it up. We've got x cubed plus 10x squared plus 32x plus 32, and it's x plus 4. All right. Now, if you'll remember back to our example there, what I'm trying to do is see how many times this will go into the first term, right? So here's what I'm going to do. This is obviously not going to be very pretty because it has 2 terms on the outside. So I'm just going to treat it. I'm only looking. I don't know where that came from. I'm only looking at the first term. X goes into x cubed how many times? How many times does x go into x cubed? Well, it goes in twice, right? Or 3 times. So in other words, it's saying if I divide x cubed by x, what am I going to get? If I divide x cubed by x, what am I going to get? Well, I'm going to get x squared. Now remember, this times this should give me x cubed, so I'm going to multiply it back through now. X squared times x is x cubed. X squared times 4 plus 4x. If you only focus on the x, the 4 is just kind of along for the ride. So again, I'm going to go back to this here. What did we do? How many times will 4 go into 5? 1 time. Multiply 1 times 4. It's 4. And then we subtracted it, right? So now I'm going to subtract all of this. Now if you notice, that changes the signs in both of them. It makes this a negative x cubed and a negative 4x, right? And then let's see what we get. We'll have x cubed minus x cubed is gone. And this step right here, if these cancel, you did it right. If they don't cancel, you did it wrong. You got to go back and check it. 10x squared minus 4x squared. I completely missed that. X squared times 4 is 4x squared. 10x squared minus 4x squared is going to be 6x squared. And then bring down the 32x. Just like we did right here, right? 4 times 4, or excuse me, 1 times 4 is 4. You subtract it, you get 1, bring down your 9. Now how many times does 4 go into 19? So how many times will x go into 6x squared? In other words, what do I have to multiply x by to make it 6x squared? Well, I need a 6x, don't I? So it's a positive 6x. We'll get into negatives in a little while. 6x times x is 6x squared. 6x times 4, that'd be 24x. And remember, I've got to come back and subtract this. So I'm going to go ahead and change the signs. I'm going to go ahead and distribute my negative and change the signs on everything. There you go, a little bit better. So 6x squared and negative 6x squared. Again, if you did this right, at this step, these should cancel. 32x minus 24x. Well, that's 8x plus 32. Then you've got x plus 4. Excuse me. So x will go into 8x. What's it missing? Well, it's missing the 8. Plus 8. 8 times x is 8x. 8 times 4 is 32. Change your signs on both of them. All right. And that gives you a remainder of 0. Or in this case, or another way of saying that is no remainder, right? All right, so let me show you this here. If there's no remainder, that means that it divides evenly. And that means that x plus 4 is a factor. Now let's talk about what that means for just a second. That means that this times this gives me what's underneath here. If it divides out evenly to 0, that means that these are both factors of what's underneath here. So what I can come back and do now is I can say f of x is x plus 4 times my answer, x squared plus 6x plus 8. Ooh, let me back up. There we are. So now I can come back and I can say that this times this will give me what's underneath my division sign, right? And it says to use the result, which is this right here, to write it in completely factored form. So the last thing I'll have to do here, x plus 4, is factor this trinomial. So x squared is x, and I need something that multiplies to 8 and adds to 6, plus 4, plus 2. that is the point of long division. Now, just a couple of notes here. If you notice back over here when I did my x goes into x cubed and I need an x squared. Alright, you see that? All my x squareds are lined up here. All of my x's are lined up here, all the way down. All of my constants, which are just numbers with no x on them, are lined up here. So everything's nice, neat, and in order. Let me kind of show you what that would look like in a regular division problem. Let's say it's 132 divided by 4. 4 goes into 1 0 times. 4 goes into 13 3 times. So you see how we line up how many times it goes in with how many decimals it is, or how many places it is. So it goes in 3 times. 3 times 4 is 12, right? And 12, 4 goes into 12 3 times. So you see how we skip that space right there? That's all I'm doing over here. I'm just saying that since I don't have an x cubed, I'm just going to go to the next space. Now, will it make it wrong if you don't line them up? No, but it's so much easier if everything is in line. It's so much neater too. It's a lot easier to stay on top of stuff, if that makes sense. It's a lot easier to stay organized if you line everything up. Now, let's go ahead and talk about what's going to happen here. If you were to have, I don't know, well, you know what, let's just do it. It'll end up being in here. I've got x to the 5th minus 3x cubed. Let me go ahead and write this down. X to the 5th minus 3x cubed plus 8x squared minus 24. Okay, now, for my sake, what I'm going to do is rewrite this question because I've got missing powers of x in here. You see that? It's almost like I've got missing placeholders. That's kind of like trying to write the number 108 with just a 1 and an 8. I need that 0 as a placeholder, right? So what I'm going to do is rewrite this as x to the 5th. I guess I didn't need to write that one up there. I'll go back and erase that in a second. Plus 0x to the 4th minus 3x to the 3rd plus 8x squared plus 0x minus 24. And what I'm doing here is going through and writing my equation so that all of my places are taken into account. So anywhere I'm missing a power of x, I'm just going to write 0 times x to that power. It's just a placeholder, right? It's only a placeholder. And I'm dividing by x squared minus 3. Okay, and again, it's only a placeholder, right? It doesn't mean anything. It's just there to make sure that I'm not missing something. So, here we go. First term, again, all I have to worry about is x squared. If I worry about x squared, this 3 will take care of itself. So x squared, x to the 5th, what's missing? What times x squared gives you x to the 5th? We're missing x to the 3rd, aren't we? So I'm going to go to my x cubed column. I'm going to write x cubed. And then multiply it back through. X cubed times x squared is x to the 5th. X cubed times a negative 3 is negative 3x cubed. Interesting. And then you change both of their signs. I'm going to change both of their signs here. Remember, when we come back and we subtract that number, we always change their signs. All right. So we're subtracting this, and again, if this first term cancels out, I know I did something correct. But then over here, day of days, this also cancels out. Well, what do I do now? Well, go to the next one. Drop the 8 down. 8x squared plus 0x minus 24. Now let's go to this one. X squared into 8x squared, what's missing? Well, the 8 is. Positive 8, right? What this is saying is that positive 8 times x squared should give me positive 8x squared, and it does! Yay! Positive 8 times negative 3 is negative 24. Change the sign! Bam! Bam! I want you to say bam every time you change a sign. That way it's drilled in your noodle up top. Bam! Bam! This will go away. This will go away. A remainder of 0. What? That means that x squared minus 3 times x cubed plus 8 gives me this monster? Fantastic. Let's write that down. So f of x is x squared minus 3 times x cubed plus 8. But wait, there's more. Because I have to write this in fully factored form, x squared minus 3 does not factor anymore, but x cubed plus 8 sure does. And you're like, Mr. Ballard, I don't remember how to do that. This is called the sum of two cubes. The sum of two cubes is a plus b, right? The cube root of this, cube root of this. So let's set it up here. It'll be x plus 2, sum of two cubes here, and then a squared minus 2x plus 4. There we have it. Not too shabby, is it? All right. Moving on. Oh, that is factored form, by the way. Yippee-ki-yay. Uno más. Number 3. We've got a power of 4 here. Let's go ahead and rewrite it. I'm going to look for missing terms. I'm missing an x squared, so I'm going to need a 0x squared here. Just a little reminder to myself. 4x to the 4th minus 2x cubed plus 0x squared minus 3x minus 9. Now, on this one, I'll go ahead and tell you up front, we are going to actually see where this 0 is going to come in handy. Didn't really help that much on number 2. This one it is. And that's 2x minus 3. Let's see if we can factor a little bit. So we've got 2x into 4x to the 4th. So what times 2x gives you 4x to the 4th? Well, you know 2 times 2 gives you 4, so you're going to need a 2. X cubed times x gives you x to the 4th, so I'm missing a 2x cubed. So 2 times 2 is 4. X cubed times x is x to the 4th. Okay, so good. I know that one's going to work out okay. And then 2x cubed times negative 3 is negative 6x cubed. Change your signs. Bam! That'll be 4x to the 3rd plus 0x squared. And I'm just going to bring down one term. You'll learn eventually, if the difference in powers of the first two is just 1, you only need this power and the one right below it. Right? So 2x goes into 4x cubed, so I'm missing a 2 and I'm missing an x squared. So I'm missing a positive 2x squared. 2x squared times 2x is 4x cubed. 2x squared times negative 3 is negative 6x squared. Change the signs. Bam! 6x squared minus 3x. 2x goes into 6x squared. I'm missing a 3 and an x. Positive 3x, so plus 3x. 3x times 2x. 6x squared. 3x times negative 3. Negative 9x. Change your signs. Bam! These go away. Fantastic. The biggest mistake people make on these is not changing the signs of the second term. 6x, bring down your minus 9. 2x goes into 6x. I'm missing a positive 3, so 3 times 2x is 6x. 3 times negative 3 is negative 9. Change your sign. Bam. 0. Alright, so that's what we've got so far. Let's take that, bump it down just a hair, and let's see what happens. F of x, I'm going to come down here and rewrite this. F of x is the outside, 2x minus 3, times your new answer, 2x cubed plus 2x squared plus 3x plus 3. And I'm going to have to factor that, so 2x minus 3 is already factored as much as it's going to get. So I'm going to group these. I've got 4 terms, so I'm going to factor by grouping. Let's pull out a 2x squared out of this one. That'll leave me with x plus 1. And a 3 out of this one leaves me with x plus 1. Let me change this to a bracket. Maybe that'll help y'all see that a little bit better. Too many parentheses can get confusing. There we go. Pulled out a common factor out of these two. Pulled out something out of these two. So f of x is 2x minus 3. And times, so bring out, these are the same inside, so I know I did something right, x plus 1 and 2x squared plus 3. Now, just to be sure, I have to look at this one. This one's fully factored, nothing I can do here. This one's fully factored, nothing I can do here. This one has an x squared in it, so I need to double check it. Can I factor 2x squared plus 3 and get good solid numbers? No, I can't. So I'm going to call that factored. So long division, take it back to an elementary stance. And you know what I actually do? I actually do this. If I ever get stuck on something, if I forget a rule, I'll go back and I'll just set up an elementary division problem like this and look at what I did. And if I can remember to myself that the process is the same, the only thing I'm doing is changing it to an equation, but it's still, this goes into this how many times? Or this times what gives me how many times this will go into here, right? And then set it up like a normal division problem. Long division to me is a pretty easy concept. All right? Y'all have a good one.